Hello, everybody. In Module 6, I discuss information processing costs and rational inattention. Module 6 has 6 lessons. Today, we focus on Lesson 4, rational inattention and portfolio under-diversification. Under-diversification is a puzzle because empirically, investors tend to hold too few assets in their portfolios, which is exactly the opposite to what standard portfolio theory predicts, a diversified portfolio. However, standard portfolio theory does not incorporate information acquisition. Rational inattention, combined with endogenous information acquisition, can provide a potential explanation of the puzzle. The big picture intuition is that investors holding assets and learning information about such assets are complementary activities, means that the higher the amounts of an asset investors hold, the more valuable it is to learn about such assets. The discussion is based on Van Nieuwenburg and Veldkamp 2010, Review of Economic Studies, Information Acquisition and Under-Diversification. The study adds a rational inattention constraint on top of a workhorse model in a traditional framework. So now let's look at the traditional framework. Investors choose to allocate wealth among risky stocks and riskless bonds. Bonds generate a certain return of R. Risky stocks generate a random dividend. Investor chooses the portfolio allocation decision to maximize the expected utility. Investors' information regarding dividends consists of the prior distribution and a noisy signal. Under Bayesian updating, this implies that the posterior of the dividends is normal with mean mu hat and variance sigma hat. Because we have n stocks, mu hat is a vector and sigma hat is a matrix. First order condition results in the demand function, which is the standard results in those asset pricing models. Investors would have a positive demand for stock that generates a higher posterior expected return than the bond, and a negative demand otherwise. In addition, the magnitude of demand is going to be larger when investors are less risk averse. It's going to be larger when the posterior precision is larger. Now we introduce the rational inattention constraint. Rather than the signal's precision or exogenous, investors can choose which signal to pay more or less attention to. So which signal needs to be more or less precise, subject to a total capacity constraint. Because information reduces uncertainty, in the normal distribution framework, that is represented by variance reduction. To make the algebra simple, we assume different stocks' returns are independent. That means the exante variance matrix and the posterior or exposed variance matrix reduced to diagonal matrices. The variance can be represented as the reduction of the diagonal elements. The paper considers 2 learning technologies. First, reduction in the sum of precision, which means the sum of the reduction in precision among the n stocks has to be smaller than or equal than some upper bound k. The second is the reduction in entropy, which can be represented by the sum of the log of the ratio of the variance reduction has to be smaller than some amount k. We also need the no forgetting constraint, which means that the posterior precision has to be no smaller than the prior precision, because prior is your starting point. You cannot forget anything from the prior. Investors' decision problem then becomes you first choose the information acquisition decision, followed by the portfolio allocation decision. The choice of information acquisition decision and portfolio allocation decision are interrelated. So we solve the model through backward induction. Whatever decision is made last is solved first. Portfolio allocation decision is made last, so it's solved first. The portfolio allocation decision still has the same formula as in standard portfolio theory. The only difference is the posterior variance and the posterior mean, which depends on the posterior variance, is endogenously chosen. And we can decompose the amount of demand into 2 components, Q-div, which depends only on the prior information, and Q-learn, which depends on how much you learn from the posterior information. We can see that for each particular stock, the expected value of the change in demand from learning is higher when the exposed precision is higher. That means investor wants to hold more stocks when investor learns more about the stock. This is the key driving force in under-diversification. We first solve for the Curry utility with additive constraint. I'm not going to explain the technical details, but essentially the solution is that if the capacity is large enough, then all stocks would have the same exposed variance, which means that for stocks with already low prior uncertainty, investors are not going to learn that. For stocks with intermediate prior uncertainty, investors are going to learn a little bit. For stocks with a high prior uncertainty, investors are going to learn a lot about that. So in all cases, investors are going to devote more attention to stocks with higher prior uncertainty. As a result, they're going to hold more, which again is in contrary to the standard portfolio theory prediction that for stocks with higher prior uncertainty, it's more risky and it should hold less. The implication of this under-diversification in portfolio allocation is empirically equivalent to overconfidence. However, in this case, investors should earn higher normal return because investors learn more about those stocks, whereas overconfidence would predict the opposite. Now let's look at the mean variance utility with entropy constraint. The mean variance utility function represents the investors' preferred early resolution of uncertainty. I'm not going to go through the technical details. The result is the solution is that investors will only learn the stock with the highest Sharpe ratio. The investor will devote all the learning capacity and only hold the stock with highest Sharpe ratio, which means for two stocks with the same expected return, investors will only learn a stock with a lower volatility, which means the one that the investor is more familiar about. What is the intuition? There is no production in this model. And because all uncertainties resolve at t equals 3, choosing the posterior variance only changes the timing of the allocation of the uncertainty. The total amount of uncertainty is the same, it's just the prior variance. Mean variance investors, they prefer early resolution of the uncertainty. And they would like uncertainty about the portfolio to be resolved as much as possible at day 2. So how can you do that? You specialize learning. You only learn one stock and learn as much as you can. This will be the most efficient way of resolving the uncertainty. Curry investors, they're actually indifferent in early or late resolution of uncertainty. So in this case, they would like to expose the variance of each stock to be as close as possible, which serves as a diversification benefit. You don't want one of your stock to have too much variance because that would be too risky. However, the feedback from learning will still result in more holding for portfolios with high prior uncertainty, which drives the under-diversification result. And learning technology also plays a role here. With additive learning constraints, if you add a fixed amount of precision, that's going to increase precision more when the prior uncertainty is high, because the prior precision is low. You add a fixed amount, that's going to increase precision more. That results in generalized learning. With multiple learning constraint, if you add a fixed proportion of precision, that's going to be more cost efficient when the prior uncertainty is low. Because when the prior uncertainty is low times the fixed proportion, the posterior uncertainty is also going to be low. That results in specialized learning. So to conclude, incorporating information processing constraint in a standard portfolio theory model would result in interrelation between what portfolio you hold and what kind of information you want to learn. The driving force is that investors hold more of the assets if they want to learn more about the asset. That could result in investors holding concentrates in a few assets that they learn a lot about, which is portfolio under-diversification. Van Nieuwenburg and Veldkamp 2009 JF paper has a similar message. They focus on how different priors of different information affects investors' attention allocation. In that paper, information with more precise prior generates more learning because investors already learn a lot about that. Investors already know a lot about that through prior. So they would like to learn more to have more information advantage. And that's the home bias that they try to explain in that paper. In the next lesson, we're going to see how rational inattention determines whether firms prefer aggregated disclosure or disaggregated disclosure. If you want to test your understanding of this lesson, check for the review quiz at the link provided in the slides. Thank you very much.